Welcome to this comprehensive 15-minute tutorial on file systems and navigation. Whether you are a complete beginner learning how computers organize data, or a developer wanting to understand the fundamentals of paths, permissions, and hidden files, this video covers everything you need to know. We will start with the basics of what a file system actually is, explore different file system types like NTFS, FAT32, Extension 4, and APFS. Then dive deep into navigation techniques using both graphical file explorers and the command line. We will demystify absolute versus relative paths, explain file permissions in detail including read, write, execute bits for owner, group, and others, and show you exactly how to find and manage hidden files across Windows, Mac OS, and Linux. In the second half, we will build a practical Python file organizer script from scratch that automatically sorts your downloads folder by file type, handles duplicates, and creates organized subdirectories. By the end of this tutorial, you will have both the theoretical knowledge and practical tools to master your file system. Let us begin. At its core, a file system is the method and data structure that an operating system uses to control how data is stored and retrieved on a storage device. Think of it as the filing cabinet system for your digital life. Without a file system, your hard drive or SSD would just be a massive pile of unorganized bits with no way to know where one file ends and another begins. The file system creates a hierarchical structure of directories and files, maintains metadata like file names, sizes, timestamps, and permissions, and manages the physical allocation of data blocks on the storage medium. It handles critical tasks like preventing data corruption through journaling, managing free space, and providing the abstraction layer that lets applications simply say save this file without worrying about which physical sectors on the disk it goes to. Every operating system has its own native file system. Windows uses NTFS, modern Mac OS uses APFS, and Linux typically uses Extension 4, but they all serve the same fundamental purpose, turning raw storage into an organized, searchable, and reliable data repository. There are many file system types, each designed for different needs and eras. FAT32, or File Allocation Table 32, is the ancient but universal format from 1996 that works on everything from cameras to game consoles, but it cannot handle files larger than 4 GB and lacks modern features. NTFS, New Technology File System, introduced with Windows NT in 1993, supports massive files and volumes, includes journaling for crash recovery, encryption via EFS, compression, disk quotas, and sophisticated permissions. It remains the Windows standard today. Extension 4, the fourth extended file system, is the Linux workhorse since 2008, offering excellent performance, journaling, delayed allocation, and support for volumes up to 1 exabyte. APFS, Apple File System, replaced HFS Plus in 2017 with optimization for flash storage, strong encryption, snapshots, space sharing, and clone files for instant copies. exFAT bridges the gap for external drives needing large file support across Windows, Mac, and Linux. BTRFS and ZFS are advanced copy-on-write file systems with built-in RAID, snapshots, checksums, and self-healing, popular in servers and NAS devices. Understanding these differences helps you choose the right format when formatting drives. Graphical file explorers are how most people interact with the file system daily. On Windows, File Explorer, Win+E, shows quick access, this PC with drives, and a navigation pane with folders. The address bar displays the current path and you can click any folder to jump there. On Mac OS, Finder, CMD plus space, Type Finder, presents a similar sidebar with favorites, iCloud, and devices, plus a path bar at the bottom you can enable via View Show Path Bar. Linux file managers like Nautilus, GNOME, Dolphin, KDE, or Thunar, XFCE, offer comparable features with location bars, bookmarks, and split views. Universal navigation tips: use the \forward buttons, Alt+left/right, press Ctrl+L, Windows/Linux, or CMD+Option+P Mac. To focus the address bar for typing paths, use search, Ctrl+F/CMD+F, with filters like type, PDF or date, last week, enable column view for deep hierarchies, and customize quick access or favorites for folders you visit often. Mastering the GUI Explorer makes everyday file management fast and intuitive. The command line gives you precise, scriptable control over navigation. The fundamental command is cd, change directory. On Windows command prompt, type cd followed by a path. In PowerShell, cd is an alias for set location. On macOS and Linux Bash or ZSH, cd works the same. Critical shortcuts: cd alone or cd takes you to your home directory. Cd returns to the previous directory. Cd goes up one level. Cd / goes up 2. Tab completion is your best friend. Type cd doc and press tab to autocomplete to documents. Use ls, Mac/Linux, or dir, Windows, to list contents. Add la, Mac/Linux, or /a, Windows, to show hidden files and details. pwd, print working directory, shows your full current path, essential when you are lost. Pushed and popped let you save and restore directory stacks for complex workflows. The command line is faster for deep navigation, automation, and remote servers where no GUI exists. A path is the address of a file or directory in the file system hierarchy. Every path starts from a root on Windows. Each drive has its own root like C or D. On macOS and Linux, there is a single unified root represented by a /. Paths use separators between directory names, / on Windows, / on Unix-like systems. Modern Python and many tools accept / on Windows too, making cross-platform code easier. A path consists of directory names leading to the final file or folder name. For example, C, users alice documentsreport.pdf on Windows or /home/alice/documents/report.pdf on Linux. The last component is the base name, report.pdf, everything before is the dir name. Paths can also reference special directories. Single dot means current directory, double dot means parent directory, tilde means home directory. Understanding path anatomy is essential for scripting, configuration files, and troubleshooting file not found errors. Absolute paths specify the complete location from the root of the file system. They always start with the root indicator, a drive letter and colon on Windows like C, users alice documents, or a / on Unix like /home/alice/documents. Absolute paths work from anywhere but are verbose and break if you move the project. Relative paths specify locations starting from your current working directory. They never start with a root separator. Examples: documents/report.pdf goes down into a subfolder, /images/photo.jpg goes up one level then down into images, /config.yaml goes up 2 levels. Relative paths are portable. Move the whole project folder and internal references still work. Use relative paths inside projects, scripts, and version control. Use absolute paths for system-wide config, cron jobs, and shortcuts. A common mistake: assuming your script runs from its own folder. Always verify with pwd or os.getcode in Python. The os.path and pathlib modules handle both types seamlessly across platforms. File permissions control who can read, write, or execute a file. On Unix-like systems, Linux, Mac OS, every file has 3 permission sets: owner, user, group, and others, world. Each set has 3 bits: read, R, value 4, write, W, value 2, execute, X, value 1. These combine into octal numbers like 755, owner, 7 equals RWX, group, 5 equals RX, others, 5 equals RX, or 644, owner, RW, group, R, others, R. Directories need execute permission to be entered. Use LSL to view permissions. The first character shows type, for file, D for directory, then 3 groups of RWX. Change permissions with chmod. Chmod 755 script.sh makes it executable. Chmod U plus X adds execute for owner. Chmod go W removes write for group and others. Change ownership with chown user, group file. Windows uses ACLs, access control lists, with more granular control via icicles or the Security tab in Properties. Understanding permissions is crucial for security, script execution, web servers, and multi-user systems. Hidden files are files that do not appear in normal directory listings. They typically store configuration, preferences, and metadata that users rarely need to see directly. On Unix-like systems, Linux, Mac OS, any file or directory whose name starts with a .d symbol is hidden by convention. Examples include .bashrc, .git, .ssh, .config, .ds_store. On Windows, files have a hidden attribute flag set in the file system metadata, viewable via a trib command or properties general hidden. Common hidden files, .gitignore and .git for version control, .env for environment variables, .bashrc, .zshrc, .vimrc for shell and editor config, .ssh for SSH keys, node_modules and _pycache_4 for dependency caches, app data and program data on Windows for app settings. Hidden files are not secure, anyone can view them with the right flags. They exist to reduce visual clutter, not to protect sensitive data. Never store passwords or secrets in hidden files thinking they are safe. To see hidden files in the GUI, on Windows 10-11, open File Explorer, click View tab, check Hidden Items. On Windows 11 also click View Show Hidden Items. On Mac OS Finder, press CMD plus Shift plus period to toggle hidden files instantly. On Linux GNOME files, Nautilus, press Ctrl plus H. On KDE Dolphin, press Alt plus or View Show Hidden Files. In the terminal, on Linux/Mac OS, use LSA to show all including .files, or lslaw for detailed list. On Windows command prompt, use dir/AH to show only hidden, or dir/A for all. In PowerShell, use getChildItemForce or lsforce. To create a hidden file on Unix, touch .myconfig, on Windows, attrib plus h myconfig.txt. To unhide on Windows, attrib h myconfig.txt. Pro tip: create a shell alias like alias lh equals lslaw for quick hidden file listing. Knowing these shortcuts saves enormous time when debugging config issues or finding cache directories. Now we build a practical Python script that automatically organizes a messy folder like downloads by moving files into subfolders based on their extensions. The script will scan a target directory recursively, identify each file's extension, map extensions to categories, images, JPG, PNG, GIF, documents, PDF, docs, TXT, videos, MP4, MOV, audio, MP3, WAV, archives, zip, RAR, code, PY, JS, HTML, etc. Create category subfolders if they don't exist. Move each file into its matching folder. Handle duplicates by renaming file_1.jpg, file_2.jpg, skip files already in correct folders, log every action to a file in console, support dry run mode too. Preview changes without moving, and accept command line arguments for source directory, config file, and options. We will use only Python standard library modules OS, Shutil, pathlib, argparse, logging, so no external dependencies are needed. This script is immediately useful and demonstrates real-world path manipulation, file operations, and CLI design. The good news: our file organizer uses only Python standard library modules, so there is nothing to install via pip. We will use pathlib for modern object-oriented path handling, available since Python 3.4, Shutil for high-level file operations like move and copy, OS for lower-level file system interaction, argparse for command line argument parsing, logging for structured.